Welcome back, everybody. This is part two of activity 32. Hopefully, you had a chance to kind of get used to, again, practicing with degree measure and radian measure. And now we're going to make the link to the trig values or trig functions of these different angles. We can do it in both radians and degrees kind of going forward. Like we saw in James Tanton's video earlier, imagine kind of the sun rotating around this circle where you can see it on the top part and then on the other side of the earth on the bottom part as it's in the sky. So how high it is that sine or the opposite. The sine is the opposite. We're using 1, that radius of 1. So it makes it easier where just that x value, or sorry, just that y value is that sine. And then the cosine is going to be how far over the sun is, that overness piece. So the cosine being the x coordinate and the sine being the y coordinate as we look at those things with it. And we want to really get really good at figuring out what those values are on the unit circle, so drawing pictures of them. Over time, you might just start to visualize in your head and know the answers pretty quick. But for right now, we want to visualize it, drawing those triangles like we saw before. And so let's take a look at some of these basic ideas again. This is on page 492 of your student notes, and so as you're looking at this, I recommend pausing to try them as you go through. Like we saw in the James Tanton video, this coordinate is 0, 1, so the cosine of 90 is 0, and the sine of 90 is 1, the height is 1. We can always start with the height being the sine. And then at 180, the sun has set, so therefore the height is 0, sine of 180 is 0, but the cosine, since we're over here in the other quadrant here, it's going to be at -1. And then we can kind of draw these pictures in for these other parts here. So as we're looking at, go ahead and pause to try it on yourself, but we're going to go ahead and draw quick pictures here. So sine and cosine for 270 would be like 390. So over here at 0, -1. So that tells me that the sine of 270 degrees is equal to -1, and the cosine of 270 degrees is equal to 0. Try -270 and 720 on your own, and then I'll reveal the answers. Okay, if you look over here, here's the solution for -270. It winds up being over at 90. It's coterminal with 90. And then 720 is 2 rotations, so it's like it didn't go anywhere. It's like it's 0 degrees. So sine of 720 would be 0. Cosine of 720 would be 1. In example B, they have you practice with radian values. Again, just we need to know how much this is around. So for that very first one, if I'm looking at theta equaling pi, that is a half rotation over here, so that's at -1, 0. So the cosine of pi and the sine of pi is equal to its height, or 0, and the cosine of pi is equal to -1. Go ahead and try 2 pi and -pi over 2. It should be pretty quick, and I'll reveal the answers. Okay, so here's those answers for 2 pi and -pi over 2. I think it's really important with the notation here to point out you're taking the sine of an angle, right? This is going to be a function that we're going to graph later. And so the input is 2 pi, or the argument is 2 pi. The output is 0. So the input is an angle in degrees or radians. The output is a ratio, like we talked about in geometry, of the opposite over the hypotenuse. It's just this time there is the length of the opposite side is 0 just because of where it's happening to land there. So it's an interesting jump from the triangles to looking at it as actually a circle. Over here, -pi over 2, rotating down again for that argument. Okay. Let's take a look at some more exciting angles in our next section. Okay, and so we're going to jump into the first part of lesson 32-2 as we continue on this, and it's going to build off of what you saw from the James Tanton video last week. And we're not going to jump to tangent yet, but again, we're going to remind you how they found the sine and cosine of some of these really special angles built off of the special right triangles we saw in geometry. And so there's a reminder over here on the left of your textbook, if you want to read through that, of where those ratios are coming from. We're on page 494, and they're going to calculate the sine and cosine of say 30 degrees, but I'm going to show you also the way James did it in his video, because I really think drawing it, if you're stuck, figuring it out, being creative and creating these triangles is going to be really, really important. So 30 degrees, they're using here this idea that the opposite side for a 30-degree angle here is always going to be 1/2. So if this hypotenuse is 1, which they've done, the opposite side is always going to be 1/2, and the adjacent side is going to be this √3 over 2 because it's longer. One thing I'll point out is that √3 over 2 is bigger than 1/2, right? And so keeping that in mind through this is going to be really, really important. And so we already recognize the x value is longer here. So the x value being cosine, the cosine is going to be root 3 over 2. The way James Tan did it is he actually just dropped this down and realized that this would be an equilateral triangle with all sides being 1. Well, if this is 1, and notice that symmetry there, this has to be a half, right? So the sine, the height would be a half. And then through Pythagorean theorem, if I call this x, x squared plus half squared equals 1 squared, you can simplify that down to find that root 3 over 2. Over time, you'll eventually start just memorizing the fact that the cosine of 30 is root 3 over 2 and the sine is 1/2, or you can kind of realize these values don't come up that often. And so you'll be able to just kind of place them on the unit circle here at the end of our activity. But again, you can always draw in triangles, use Pythagorean theorem, all the tools you've had in geometry to help figure things out. They can also give not just angles in degrees, but also in radians. So we see that here in example B. 7 pi over 4, that's just short of 2 pi. So 1 pi over 4 is short. So in reality, if I'm thinking about this, this is pi over 4 for that reference angle, or 45 degrees. So this is a 45 degree triangle, so I know these are equal sides. I just don't know how much, but if I call them, say, x and y are going to be the same here, so notice our sines are going to have roughly the same value. I have x squared plus x squared equals 1 squared. Working from there, I get 2x squared equals 1, x squared equals a half, x is equal to the square root of 1/2, which is 1 over root 2. You do have to technically simplify that by getting rid of the radical in the bottom. So I'm going to multiply by root 2 over root 2, that sneaky form of 1. And that has to be root 2 over 2 for that value. And then I'll point out very, very importantly here that the cosine value is positive, root 2 over 2 here. We see that. But the sine value, notice, is going down. The sine value is going down, so that has to be negative root 2 over 2. So a lot of these different values are just going to be shaped by what quadrant they happen to be in using these special right triangles. 45, 90. Notice here root 2, if I have 1, 1, and root 2, going backwards from that, the other pattern that you might want to realize is that if you have 1 as your hypotenuse on the other hand, is you're going to get this root 2 over 2 value. Root 2 over 2 it's a strange number, I get it, but root 2 over 2 is slightly bigger than a half, and it's slightly smaller than root 3 over 2. Just think about root 3, right? Root 3 is bigger than root 2. So as these angles start to rotate around, you're going to find that the 30 is 1/2 up. Think about the height. The 45 is going to be at root 2 over 2, and then the 60 is going to be at root 3 over 2 up, and then all the way up to 1 being that next highest value. So again, this rotational idea is going to keep coming into play. So you can use the triangles, but eventually you're going to have this visual picture at the end of this lesson to kind of help build it. So let's take a look at a couple more examples. Okay, so how do we find the sine and cosine of any angle that they happen to give us, and so become more familiar with this. The homework part for this is going to be filling out a lot of the common angles that you'll see next, but we'll walk slowly through them. I've got these circles pre-drawn in here. These are all unit circles, so they're all radius 1. And so I'm going to look at 300 degrees and just draw that onto my picture first. So 300 is going to be over in quadrant 4. It's going to rotate all the way around, and then it's going to just be just short here. Remember, this is 1. This is 300 degrees. It is 60 degrees short, right? So it's got that 60-degree reference angle on that particular one. So I've got a couple options here. I know this is 1. I know this is 1. If I'm thinking about James Tanton's video, I might think about this a little bit differently and say, okay, well, so that's 30 degrees maybe for that little piece here. And if I reflect it here, that's also 1. This would then be 30 and 30, so 60 degrees for that portion right here that I'm highlighting. And so that makes this one along the xy, which makes this portion a half. Now that's the overness, like James Tanton talked about, so that's my cosine of 300 degrees is going to equal 1/2. Now what about the sine? The sine is going to be that height piece. So let me put that in red here. That height piece here. Now using symmetry from before or Pythagorean theorem, I know that half squared plus uh, this y value is going to equal that. So again, I could go through that. Y squared plus half squared equals 1, because 1 is this hypotenuse here. Or I could use that 30, 60, 90 pattern that says I'm going to be root 3 over 2. And what we'll find is these values, sine of 300 degrees is going to equal root 3 over 2, and it's going to be a negative root 3 over 2. That's going to be really, really significant here. I'm in quadrant 4, so the cosine is positive and the sine is negative, because the cosine is the x-coordinate, the sine is the y-coordinate, as we think about those things. And again, most of the time you're going to be using halves, root 3's over 2's, or root 2's over 2's if it's these common 45-degree type angles. So let's keep drawing these. You'll get more used to it as you go, and eventually, like I said, it'll become more natural to you. Half is smaller than root 3 over 2, as we see here. All right, next example, negative 225 degrees for example B. So let me go ahead and draw that. Negative 225, so negative 180, and then another negative 45, so it's going to come right out into the middle here. So while that's negative 225 degrees, its reference angle of 45 degrees is right here. I'm looking for its overness. I realize that this is going to be a 45, 45, 90, so actually my sine and cosine for anything with 45 degrees is going to be equal to each other. We saw before with the 7 pi over 4, that was that root 2 over 2. You can go through Pythagorean theorem again, saying, okay, x and y are the same thing. What's x squared plus x squared equals 1 squared? And solve. But at this point, hopefully you're starting to see the patterns here. This x and y, the sine and cosine, are going to be at root 2 over 2. But notice it's in quadrant 2, so the x value's got to be negative, and the y value's got to be positive. So the sine of negative 225 is going to be root 2 over 2. That's the height of the sun. And the cosine of negative 225 degrees, its overness, is going to be negative root 2 over 2 because we're over in that other quadrant, like we saw in the James Tanton video. And again, you could use Pythagorean theorem again or the 45, 45, 90 pattern, but at this common number of root 2 over 2, like we saw in example B up above, is going to carry over. All right, let's keep going. You're going to see root 2 over 2, root 3 over 2 and a half come up lots and lots and lots. All right, so 5 pi over 6. That's C, 5 pi over 6. So that is not quite pi. That is, pi is one time around, or a half circle. So I'm just short here. I'm 1 pi over 6 short. So that means this is pi over 6 for my reference angle, or 30 degrees for my reference angle. So if I think about the height and the overness is more, the cosine is more. So the cosine of 5 pi over 6 is what I'm looking for, and the sine of 5 pi over 6 is what I'm looking for. Cosine is going to be bigger, sine is going to be a little bit smaller, cosine is going to be negative, sine is going to be positive, just with where I am on the unit circle. And again, since that's 30 degrees, I could do some interesting things with this being a radius of 1. I could make that same triangle equilateral like we saw in the video. And that forces this, if the whole side is 1, that forces the height to be a half. So sine winds up being 1/2. That is positive. However, for the cosine, I'm over. That's going to be that negative root 3 over 2 because I'm in that particular quadrant. And again, I could get that from Pythagorean theorem or from the 30, 60, 90 pattern we saw from before. And then finally, letter D, I'm looking at negative 4 pi over 3. So negative 4 pi over 3, so I'm going to rotate. So that's negative 1 pi, and then I'm another negative pi over 3, which is 60 degrees, right over there. So it's important to recognize which angles are most important here and how much each is. So again, reference angle-wise, this is negative 4 pi over 3 overall, but the reference angle here is going to be pi over 3 or 60 degrees in terms of that. So it's going to influence our triangle here. So again, I've got this 30, 60, 90 pattern with this radius of 1, or I could reflect it across the other way, like we've seen before. So what is the sine of negative 4 pi over 3, or the cosine of negative 4 pi over 3? Well, its height looks bigger than its overness, first of all. And we've already seen that the 30s and 60s are dealing with these halves and these root 3's over 2's. So which one's bigger? The height is the bigger one, so the height's going to be that root 3 over 2. And half is smaller, so half must be the overness. Again, I'm in quadrant 2 here, so that's going to be a negative 1/2 for that x coordinate. Negative 1/2, comma, positive root 3 over 2 for that x and y coordinate. And so if we were to put all these angles onto the same circle, we would have a really nice graphic organizer of that, and that's where we're heading next. So go ahead and pause, and we're going to show you what your homework is for this portion. So I'm going to put on Schoology, and we'll probably use it every day, just a real quick kind of flashcards of different angles converting between degrees and radians, so you recognize which angles are which radian measures, and that just starts to get tattooed on your brain. And we know now the x value is the cosine of that angle, the y value is the sine value of that angle. And you see a few labeled around here. Using symmetry and the fact that quadrant 1 is both positive coordinates, quadrant 4 down at the bottom here, notice it's positive on the x coordinate, negative on the y coordinate, just like it's always been. We can use that to influence what sign these different root 3 over 2s or halves are. And again, the sine, the height, is going to be taller here. Root 3 over 2 is taller than 1/2. So if I reflect that over here, let's say, I could draw the triangle in, but again, using symmetry, 2 pi over 3, that's also going to have a height of root 3 over 2, but now its x value of 1/2 is going to be to the negative side. So we see how there's a reflection from this point to this point. And then there's a reflection from this point down to 4 pi over 3, negative 1/2, negative root 3 over 2, because now I'm down on the bottom. Your main homework for this, besides the flashcards of matching radians with degrees, is going to be taking this graphic organizer and seeing if you can fill in all the cosine and sine values for all these common angles. Okay, so try to fill that in. Over time, this is going to be something that you reference. Hopefully over time, it becomes something you're able to visualize in your head or draw like we did the previous examples to help. And we'll practice more with this next Tuesday and start calculating the tangent value with it as well. So again, hopefully that's helped. Please reach out during the Zoom office hours because I know this is brand new stuff and it can get a little confusing at times, but hopefully you're working hard and becoming a much better independent learner. I'm always here to back you up and help you as much as I can. Take care. Don't forget to finish this unit circle as your homework. You can download a blank copy on Schoology.